So, welcome everybody and good afternoon. Thank you for attending this webinar organized by EURO-NMD in partnership with the European Academy of Neurology and the Rare Neurological Disorders European Reference Network. Today's speakers are Giselle Bon, Carles Hernandez Ferrer, and Katia Woman. Giselle Bon works on the Sorbonne University in CERN's Center of Muscle Research and in the Institute of Myology at Pitié-Salpêtrière in Paris. And she will introduce us to the Treatabolome, which is a task of the European project SOVARDI. She will present the concept behind this initiative to bring visibility to existing treatments for rare diseases in general. Carles Hernandez Ferrer is a researcher at the Data Analysis Group from the Centre Nacional de Análise Genómica, CNAG-CRG, in Barcelona, and works on pipelines for genomic and genomic-related data analysis. He will explain the development and architecture of the platform implemented to harbor the Treatabolome database. And Katia Lohmann is Vice Head of Institute of Neurogenetics and Section of Clinical and Molecular Neurogenetics in the Department of Neurology of the University of Lübeck and the corresponding hospital facility. Katia is in the coordination of the MDS Gene Database for rare genetic forms of Parkinson's disease. She will explain the interaction and symbiosis of the two digital tools, meaning the MDS Gene Database and the Treatabolome, and how they together are stronger than separated. So thank you all for agreeing to give this talk. I'm going to stop my sharing, and please, Giselle, the floor is yours. You can start the sharing and your talk. Thank you.
Thanks a lot, Antonio, for the kind introduction. And it's a great pleasure for me to be with you today. And with no further ado, I will start my introductive talk to this webinar on the Treatabolome. So as Antonio said, this Treatabolome project is part of a larger European project called SOVARDI that aims to speed all the tools to unsolved rare disease cases that remain undiagnosed. So as you can see, this Treatabolome project gather a large number of people involved in order to set up this Treatabolome database. And I will try to introduce you where it comes from and where do we go. And I would, first of all, acknowledge all the people involved in this project, and in particular, Antonio Atalaya, as it has been the chef d'orchestre, director for this. So, what do we mean by a Treatabolome? A Treatabolome in the field of rare disease with emergence of the next generation sequencing and the high throughput technology, a rising number of genes and variants has been described. This has speeded up the diagnostic for a lot of patients, but still there is a growing number of genetic diagnoses that correspond to specific treatment. Many are genes or even exon or even variant specific, but it's still quite difficult to connect and to have the knowledge of all this very detailed and very specific treatment for every genes, every disease. And when patients first face this for their rare disease, on average, they usually wait almost 4.5 years waiting for the right diagnosis. we aim to try to shorten the next odyssey, which is the treatment odyssey, because at the stage of the molecular diagnosis, if a treatment already exists for this specific variant in this specific gene, it will be much easier if we have a database that links directly existing treatment at the stage of the diagnosis. But for now, no such database exists, and that was the aim to set up these databases within our Solverdi project. So what is the Treatabolome? As I just said, it is a database. It is aimed to be interoperable using FAIR principle of all databases nowadays. And within this database is a list of gene and variant-specific treatment, and eventually for every rare disease. And to fill this database, we initiate the work to feed it by data set assembled by experts on specific rare disease, and we use the means of a systematic literature review of existing treatment for specific disease group. So the first proof of concept was made using some neuromuscular disorder, and this has been set up by the team of Hans Lochmüller with Rachel Thompson as a lead, and they take the congenital myasthenic syndromes as a use case, and they assemble a systematic review of all existing treatment for the different genes leading to congenital myasthenic syndromes. And this was the very first paper highlighting and presenting this treatabolome concept. Then within the project, we gather different experts of different disease, essentially to start with of expert of neuromuscular disorder, as it was the first step towards this. And we decide that to help with this systematic review of the literature, that we need to prepare a guidelines, to assemble those systematic review. And Antonio, in connection with all authors highlighted in this paper, prepare a guide for writing those systematic review, including all the necessary items that would ease the work behind the scene to feed this paper, this data set collected during this systematic review in 90 tools, as Carles will present it you afterwards. So we use all the means already existing, like order codes, any codes that exist from clinical point of view and genetic point of view, and even for treatment, to be able to link all this knowledge together. So what is in the Treatabolome? Don't worry, I don't go into the very deep detail of this slide. It's just to highlight that the guideline paper provide guidance how to assemble all the necessary items for the IT teams afterwards. So you code the publication, the clinical information, the study information that led to the treatment, the variant and gene information, and the treatment. Okay, and so there is codes for all those items, and this is what is needed to extract from the systematic review that expert of every disease has to make. So far, we had been able to connect several experts, and we had a chance to get expert-led systematic review on congenital myasthenic syndrome. I just presented you. We had one on laminopathies, one on muscle channelopathies. The one on ataxia is still ongoing, but we hope to have it soon. We had one on metabolic disorder, focused on Leigh syndromes, mitochondrial disorders, Parkinson disease, and peripheral neuropathies. And all, and you have on this slide all the PubMed ID to find them easily. And we have assembled, we had the chance to have a special issue of the Journal of Neuromuscular Disease, in which we presented the concept again and had the publication all of these systematic reviews. And you can find this issue, and these are the different papers that has been published. So for experts who want to make a systematic review, it's a way to valorize the workload, the work spent to assemble all this data. So you will have the data set fed in the IT tool and accessible as Carles will present it. And at the same time, you can publish the systematic review to be also largely diffused in the community. So the first public version of the Treatabolome database will be soon released. It will be first integrated to the RDConnect GPAP platform, which is connected within the Solverdi project. We have discussion ongoing for the next step for how to update and implement the dataset using other means than systematic review only through crowdsourcing initiatives. And we will also include new ontologies for treatment, for example, MAXO or PUTCHEM. And of course, I'm there to advertise this project, this concept, this tool, and I would like you to diffuse this project around, and your current rare disease data could be part of the Treatabolome database, and you can start your systematic literature review on your preferred rare disease. And please just contact us to be connected and be able to feed your data set in our Treatabolome database. And with that, I will leave the scene and the microphone to Carles, who will present in more deep detail the tool behind this concept. Many thanks for your attention. Stop sharing.
Thank you, Giselle. I start now sharing then. Well, I'm Carlos. I'm from SINAC in Spain, and the team where I'm led by Sergi Beltran. It's somehow the responsible on making this Treatabolome concept a reality. And I'm going to introduce very briefly, and I will do my best to avoid any technical wording, the database and the web interface behind this Treatabolome concept. But before starting, I want to go in a bit more detail on this slide that Giselle skipped a bit, and so to give me more time to go try to make this more comprehensible. So behind this Treatabolome, there is a knowledge model that we had to transform to a data model in order to store it in a database. But which is this knowledge model? So this knowledge model is somehow 5 entities that they are related all together. And since we started this project from the systematic literature reviews, the first concept is the publication we are reviewing. this publication in the Treatabolome at this moment can have 4 origins. Can come from PubMed, from clinicaltrials.org, EURO-NMD, and Cochrane. Once we have the publication we want to review, we need to extract some information from the publication. And the first one is the clinical information or the diagnostic of the patients that are analyzed on that publication. How we perform this characterization of the patient. In Treatabolome, there are 3 fields that you can complete in order to perform this characterization, and one of them is mandatory. It's you need to provide an ortho term from Orphanet, and this one is totally mandatory. But then you can go a bit further and try to improve this characterization, providing 1 OMIM or as many HPO terms as necessary in order to complete this phenotypic characterization of the patient. The third entity or the third concept is the study that it's being described in this publication. What type of a study is? It's meta-analysis, it's a letter, it's a case study. And then while this definition of the study is mandatory, we encourage to provide some sort of evidence score for this publication. And this evidence score are defined with the OCMB and the grade scores that, although they are optional, we strongly encourage the performance of the systematic interviews to compute them and to provide them. Then, once we have the clinical characterization, the study type, we go for the gene and variant information. And in this scenario, we need the gene and the transcript where the variant is located, and the variant in the cDNA form. If possible, we also would like to collect the protein form, but this is totally optional. And I'm responsible to convert the cDNA to the protein one if necessary. And we will also like to have the inheritance model of this variant. And finally, we need the key concept, which is the treatment. And the treatment in this case, it's just the treatment applied on this clinical link to this genetic scenario. And at the moment, we use KEBI and mesh databases in order to collect this information. So as a summary, we have these 5 entities or these 5 concepts that are all related across them. And we are using kind of well-established ontologies in order to code all of them. So at the end, we will be able to make this database easy to use and easy to connect with other systems. Now, I'm going to try to go very fast in 2 examples of how to collect this data. So this is a publication related to congenital myostatic syndrome, CMS. So the first issue is to extract the PIMID ID and the type of publication. Then we start reading the publication and we try to gather the clinical information. So we define an ortho, we define an OMIM, and for this example, we could not gather any HPO, no problem. We continue reading and we gather the information about the gene and the variant. So we identify the gene, we identify the transcript, we were able to identify the cDNA variant, and also the protein. Perfect. And we continue reading, and at the end, we are able to identify the 2 treatments that were used to treat these conditions. So with this information, we're able to enter this publication in the Treatabolome. And at some point, once we process it, it will be able to be queried on the database. Another simple example. So in this situation, we have a case report. Same situation as before, different ortho term, another OMIM, but no HPOs. We continue reading. We're able to identify the mask gene, also the transcript for this gene, and the variant as a cDNA, and also the variant as a protein. We continue reading, and we're able to identify that in this case report, they were testing 2 different drugs. So this will be the information that we need from this publication. How, once we're able to identify all of this, how we make all this information available, or how we provide this information to the team who will make this information available. So we provide a template as an Excel file that has many columns, a column for each piece of information that we need to make Treatabolome work. And then the people who is doing the systematic data reviews, once they start collecting all this information that they show you, that they put it on those Excel files. So here we have 2 examples. If I'm right, the one on the bottom, it was the one from Antonio on his systematic data review on laminopathies. And I will now go as to perform a live demo of how the current version of the database works. But to start this live demo, we need something to query, some seed. So let's imagine that we have this clinical description of a 42-year-old male that has some symptoms: proximal muscular weaknesses, difficulty walking, urinary incontinence. There is no relative with any of these symptoms. It seems that the onset age was 30 years old, and we end up with a clinical diagnosis of glycogen storage disease. Let's at the moment forget that we can have also a molecular diagnosis. Let's just go for the clinical diagnosis. So this is the Treatabolome database. Brief overview. On the left, this square panel here, it's showing a brief description of what we are observing in the central part, which is the results section. And then the one on the top allows to perform some filtering.
Sorry, Carlos,
yeah.
We are not seeing your live demo.
Okay, I'm going to stop sharing and start sharing again. So are you able now to see the Treatabolome webpage?
Perfect.
Perfect. Okay, I'm going over. On the left side, we see a brief summary of the main results, and the main results are located in the central part of the page. And then the blue square at the top allows for a very basic filtering criteria. So coming back to the clinical case that we were dealing with, I said that the clinical diagnostic was about glycerin storage disease. So we can come here to the clinical diagnosis and look for this glycerin storage disease. Since the onset age was 30 years old, we will select the late onset. And then here we already see that the information stored in Treatabolome all point to the gene GAA, and we have 17 entries related to this clinical diagnostic and this gene. On the central part, we will see that, well, again, this summary of 17 entries, and we have some summary about the results. So we see that the alglucosidase alpha is the most frequent treatment. So 16 treatments over 17 entries. So this will already help us in order to see which is the possible treatment for this patient. Okay, let's now go to the molecular diagnosis. So we know that the targeted gene that we are interested in is GAA, and we also know the genotype. And we can go on the other side. Imagine that we don't have the clinical diagnosis. So we can come here, I select everything. So we could go directly to select the gene on this side, GAA. We see that there are 45 entries, 28 corresponding to the infantile onset and 17 related to the late onset. So we could click the ones related to the late onset, and we will observe again that the most frequent treatment is the glucoside alpha. Then, on this version of Treatabolome, we are still not capable to filter by variant, but we are working on it. So, but anyway, according to the clinical case, this is the variant that we are interested. Therefore, we could go to see the full details of this entry. And from here, we could consider using this treatment as possible treatment for our case. Coming back to the slides. As Giselle said, as a future work, which is not really future, is work that we are doing at the moment. We are going through the second round of curating the data obtained from the systematic literature reviews, because the main goal of Treatabolome is to make this database interoperable and being able to work with other tools. So we need to include extra fields required to archive this goal. At the same time, we are developing the API, the application programmatical interface, that will be used for these other systems in order to operate with our database. And we will make our proof of concepts integrating Treatabolome with RDConnect genome phenome analysis platform. At the same time, we are trying to collect as many feedback as possible on how to use this web interface that we developed. And we plan to update this web interface quite frequently in the following months. And we are considering adding new ontologies. And as Giselle said, some of the ones that we're considering are Maxo and Bootcamp. And I would like to thank Giselle and Antonio for all the effort that they put on this project, as well as Sergi, the team lead, the bioinformatics unit in the SINAC, and the team there. Well, I think that we will have the questions and answers at the end, but just let you know that I'm happy to take any question you may have.
Okay, thank you, Carlos. Perhaps you can now stop your sharing, and we'll leave the questions to the end, as you said. And Katya, please go ahead. The floor is yours.
Thank you, Antonio, and I would like also to thank Giselle for giving me this opportunity and for her nice introduction. And I would like to present one of the examples how the data actually get generated for the database. And I'm one of the examples that Giselle mentioned where people that are already working on systematic literature reviews or have a specific expertise in the field can get involved into the Treatabolome project. And this happened to me when I participated in the Solve RD workshop in Nijmegen 2.5 years ago, so before the pandemic, where we met with a lot of people. And I heard about this project, and it requires systematic literature reviews to build the Treatabolome database as one of the approaches to do so. And at this time, I was already involved in generating systematic literature reviews. I'm a molecular geneticist working in movement disorders, so not neuromuscular disorders, but another neurological disease, and with a broad spectrum that I'm working on, but with a main focus on Parkinson's disease and dystonia. And like 5 to 6 years ago, we recognized that the nomenclature system of many of the movement disorders genes is a bit, let's say, outdated. It had several problems. And so we decided as a group to build up a new nomenclature system and suggested this. And when we tried to put the data together for all the known movement disorder genes, and we really wanted to link the gene to a very good phenotypic description, we realized that even the experts, so the really best experts in the field, that they have had difficulties to have a complete overview on the phenotypic spectrum. And so we, based on this, we thought, okay, the solution would be that we generate a database based on a systematic literature review on movement disorders patients. And we had two main aims. One was the genotype-phenotype correlation. But the other one that we had to develop and that we wanted to use is, and this is also, and then applies for the Treatabolome, you don't want to have patients in your database that actually don't have a disease-causing mutation. You only want the ones with a pathogenic variants. And sometimes this is really does not become clear from the literature. So we had really to also do pathoscoring for each of the variants and only included the ones that were not scored as benign. And just to mention it, so the movement, so MDS Gene stands for the Movement Disorder Society Genetic Mutation Database. And by now it includes almost 9,000 patients extracted from 1,500 publications with about 2,500 different variants. And it's not only covering Parkinson's disease, but as I mentioned, several other movement disorders. And we are a team working on this, and it's mainly located in Lübeck and Toronto, but researchers and clinicians from more than 100 sites are included into this effort. And we have a coordination team and documentalists and, of course, a programmer and statistician to help with the data analysis. And how it works, and I think this is similar for all the systematic literature reviews that go into some database, is that you first need to define your target or your disease group or your gene group that you would like to address, and a group of experts is formed and to do the actual work. And to do the actual work, you need kind of pre-abstraction work first. So this means you need to get the articles that you would like to systematically screen, and so you need to define your search term and what you would like to get, and then the actual work starts with the abstractions of the article. So you really have to go through each single article, and we do it stepwise. So we start with a title. Sometimes the title you already know that this is not what you are interested in, and the abstract. And if both is promising, let's say, then you go to the full text and abstract all the data. And then the next step is the curation of the genetic variants and also of the pathoscoring, as I mentioned before, to exclude benign variants, because you don't want to have these patients in your database. And then there is some upload to the database and the quality control, and finally the final upload and the data analysis and systematic reviews to be published, and which is ongoing and should be done for all the databases are updates, and but these are usually not so well recognized, and and it's also a lot of work. And I just would like to give you a few examples how the MDS Gene Database looks like. I mentioned that you have these different genes, and it's still a growing list, and you can then select the gene of interest. I would like here to start with one, basically with the first gene that has been linked to a monogenic form of Parkinson's disease. And if you go there, you get a list with the publications, and this is many of the things are basically hyperlinked. So if you click on the first author and years, and you come to PubMed and can have the full article. And you can also have at the top the information about the clinical features of mutation carriers in this gene, and you get a lot of information in several display items. For instance, in the upper level here, you can see the clinical features sorted according to the frequency, and we have 3 colors here. In red is always if the sign is present, in blue it's when it's absent, and in gray if there is missing data. And you already see here that for a number of even the very core clinical items, there is missing information in the literature. And we also have data on the mean age at onset and the first symptoms, the frequency of mutations, the ethnicity of the reported patients, the country of origin. And in MDS Gene, it's not a main topic, but we have a bit information on treatment. As you may know, for Parkinson's disease, the standard treatment is levodopa. And so we have levodopa response as good as it is available. And you see that the majority of patients respond well, but there are also some patients that don't respond that well to levodopa therapy. And you can also have genetic information in this database. So you can click on the specific variant and you get a lot of additional information, different types of annotations, as well as the number of published individuals and the PATHO scoring. So the interpretation. And you further, you can also select specific patients. For instance, you would like to focus on index patients only and on only definitely pathogenic variants. And then you can, again, have all the patient characteristics in the same diagrams, but in a filtered way. And just to give you one little example for possible genotype-phenotype correlation given from this alpha-synuclein gene that I just showed you the actual data. Both duplications and whole gene triplications are pathogenic, so are disease causing. But in these diagrams, you see duplications usually have a bit slighter, later age at onset compared to the triplication cases. This is something what you would expect as more gene you have, as more severe the phenotype gets. But this is only one of the levels. And actually, you would really like to also link this to the treatment. And for this, we started with a detailed abstraction of the treatment data from the literature. And so in 2018, we just had published systematic literature reviews on phenotype-genotype correlations for the 6 genes that can cause monogenic forms of Parkinson's disease. And since we are talking about rare diseases, so all of you probably know Parkinson's disease is one of the most common diseases, but when it comes to genetic monogenic forms, they are really rare. And you will see this later at the numbers that we could use for the Treatabolome database. So we started basically with the papers that went into these 2 papers from 2018. Plus, we did an additional update in 2020 to include novel articles. And we started with almost 9,000 papers. But after filtering and looking for available or informative data, we ended up with less than 500 publications. But still, this is a lot if you really have to go through all these publications and read them carefully. And this slide here gives you some information on the number of patients that have been identified or have been reported and could be included in the Treatabolome. And you can see here that there are in total a bit more than 2,000 patients or mutation carriers. But if you look here for where really a response was reported, this was only available for less than half of the individuals. But if you look at the response in these individuals, it was mostly good, but data were limited, and there are some differences among the genes, but not like black and white. So some mutation carriers respond a bit better than others, but there are no dramatic differences. And just to illustrate how we put the data together, going back again using alpha-synuclein as an example. So there were 146 patients available, and we listed all the different mutations or the mutations separately that occurred in many patients and grouped the more rare variants. And as you can see, the information on levodopa response was only available for something like 2/3 of the individuals, but most of them responded well, but not all. And you can also see that there is a quite range for the doses of levodopa that has been used. And you can also see that when you really break it down by different by the different mutations, that the numbers become quite small and you cannot really draw meaningful conclusions. And when we go further, that we look for side effects, the information really becomes much more or less. So we started with 146 individuals, and here we only have 31 individuals with information. You can also expect that maybe there are no side effects in the other individuals, but this is rather a bit unexpected. So there is probably also here a publication bias. And finally, in addition to the levodopa medication, There's also surgical interventions, mostly deep brain stimulation. And you can also see here that the number of individuals is very limited that has been reported, but all of the reported individuals showed a good response. So this is just to illustrate how the data could be illustrated and graphically presented. But if you really have a patient, as Carlos presented earlier, and you would like to know what to do with this patient, this is not really doable to read or through the articles and to look in the diagrams and search for possible information that maybe might not be there, because maybe your variant is among the other variants. So that's why there is really a need for the Treatabolome database. And as Carl just presented, we had to feed the database with the data, and this were basically a large Excel file with many, many variables, and each patient in a separate line. And so the conclusions from our experience and what we would suggest for the future is coming first for the PD Treatabolome, and what was the outcome was that there is no major influence of the genetic course. So all the 6 genes more or less behave the same, and they all have more or less the same medication. So this is important information. If you are not from the field, this is good to know that you don't have to worry too much about the specific mutation or the specific gene that is mutated. But this might not be generalized, because maybe in novel forms or atypical forms or other forms of monogenic PD might have different medication response. Another point is that it was for us challenging to disentangle disease progression. As you know, Parkinson's disease is a neurodegenerative disease, so there is disease progression over time, and side effects, because sometimes it was not really clear if the co-occurrence of dystonia was a side effect of the medication, for instance, or if it was just part of the disease progression. So this can only be overcome by systematic large-scale studies. But as I mentioned, it's a rare disease, and so the studies can only be as large as possible. And as I also hope to indicate it, it's a lot of work. So starting with more than 8,000 articles and to go through all the titles and to some of the abstracts and to some of the papers, this is really a lot of work. And that's why it's, as we did, it's a good idea to combine things. So to abstract the phenotype, to abstract the genotype, but also to abstract the treatment at the same time. And this is something that we probably will do also then when we come to the updates. And what is also an issue is that there is limited data in the literature. So I showed you that there are only a few patients published, but that the information on treatment data and also on clinical data is very limited. So it's often not reported or not correctly reported or not in detail reported. So this could be definitely be improved, but it's also necessary to include unpublished data, because the standard patients usually don't get into the literature. And but the unpublished data also need to have some process of validation. And we should also keep in mind that there is publication bias. So usually, as I just mentioned, unusual cases are reported or only reported after 2 or 3 years after gene identification. And also it's important that authors are honestly, because there is a tendency, if one of the medications that you use did not work, you usually don't report it because it's not the best thing to say for yourself, but it helps other people. And if such reports are recurrent, then it becomes clear that's maybe not a chance finding, but that it has to be with a disease, and it's important for other people. And altogether, I would like to say that the systematic treatment data provide an overview to experts, but also to non-experts in the field, in terms of what to give to the patient, when and how much, and when not, and all these things. So it's definitely helpful for all clinicians that would like to treat their patients in the best possible way. And with this, I would like to thank you for your attention and the MDS Gene, so by my co-PIs from the MDS Gene and also our current programmer. And on the Parkinson's disease Treatabolome, Norbert Brüggemann was involved as our main neurologist with a lot of experience in treating PD patients and putting the different medications reported in the literature into the right context and categories. And Laura Over, who was the first author, was a medical student and did the actual literature research as part of her medical thesis with us. And finally, I would like to thank the Solve RD members, Giselle and Antonia, and the CINAC team for this really nice effort and experience. And I think it's very important to continue with the work. And I would also like to thank our funding sources. Thank you.
Thank you, Katja, and thank you all, Giselle and Carlos. I would like to remind everybody that they are now unmuted. So if you want to put a question, you can unmute yourself and put it. Perhaps first raise your hand so that we can organize the order of putting the questions. But as usual, people are a bit shy at first. So I'm going to have, as always, the privilege of putting questions. And I would start by one that I think is important to understand the usefulness of this platform, and it's addressed primarily to Carlos. So Carlos, can you explain, please, in a kind of reduced form what GPAP does and how such a diagnostic support tool can incorporate the treatable information and how that can be useful, as Katja was just saying, not just for the ultra experts, but to the increasing multitude of clinicians that by necessity are starting to ask for diagnostic tests and finding pathogenic variants, and how that can, the fact that Treatabolome is interacting with the diagnostic support tool, how that can be useful for the common clinician using the platform.
Okay, not tricky question, complicated question. So RDConnect GPAP is a web application that CINAC provides to everybody that wants to collaborate with us or in any project where we collaborate. And the idea is that we perform some sort of whole genome or whole exome sequencing data, or you provide this data to us. And then we perform a series of transformation annotation to the data. And this data is inserted in a specific and very special database that we built. And then the RDConnect GPAP is somehow the web interface that allows you to query this specific database. So you have your patient of interest, maybe some relatives, or not. I mean, it's not mandatory. And with the GPAP, you can somehow perform a series of filtering criteria in base of a third-party database or some knowledge that you may have related to their clinical diagnostic or their phenotype of that patient, and end up with a very specific list of variants that somehow should be the responsible of the condition of your patient. So the relevance of Treatabolome will be that once you have these variants, you will directly have the link to possible treatments, or at least to treatments that in other circumstances have already been used.
Yeah, thank you. So the other thing that I think it's probably important to stress is the crowdsourcing mechanism that you are planning to put in place. So right now, the Treatabolome is triggered for each disease area by doing a systematic review according to the white paper that was published. But this is a one-off thing, so we won't ask people to be doing systematic literature reviews and every time there is an update to treatment. So it's easier to basically include that update in the database in the form of a new variant with a new treatment or whatever form it takes. And for that, we were thinking of crowdsourcing. So and that's a question for everybody, for Giselle, for Katja, and for Carlos. So how do you think the crowdsourcing could work for this? How do you imagine that the things could be run? That's an easy question too.
Yeah, super easy. From our side, at least, thinking more on the technical side, we always envision this some adaptation of the known panel app application from the UK Biobank, where somehow any researcher can create a profile there, and after some very basic validation of the credential of that researcher, this researcher can provide or can enter to the database one register in Treatabolome. Let's say I had this clinical diagnostic, I identified this variant, I treated with this variant, and this was the consequence of this treatment. And once this registry or any registry that any researcher wants to provide, with some periodic, we will trigger some periodic validation of these registries. How we will do this validation, it's still something that we need to discuss, but following the model from Panel App, somehow there will be two rounds. One again on crowdsourcing, where the other researchers could say, yes, this relationship is correct, or no, this relationship is not correct, or maybe yes. And once we end up with this round, if the result is no, it's directly discarded. But if it's yes or maybe, we could invite a panel of experts to just go and just say the final result for any of these relationships. Once this is done, then it will be moved directly to the web application, so everybody could benefit from this new knowledge.
Okay, so Katja, thank you very much. Your presentation was very clear. In fact, it withdrew the possibility of putting some of the questions I anticipated for you. And so I'm going to ask you a more difficult one, of course. So are you thinking of using also a crowdsourcing mechanism for updating your database or not?
Yeah, actually, we are discussing this for a while internally. The problem with this account, as Carlos also just mentioned, is that you have to have some kind of validation of the data and also some systematic way to collect the data. So we are not yet at the stage of having this unpublished data included. We had one pilot for for a related disease, for dystonia, for a combined symptom with dystonia and Parkinsonism, where we used unpublished data. But this is and only for the genotype phenotype, not for the treatment. But this is a type of very it's basically an endemic disease with a small number of individuals and a small, let's say, community where really all individuals that treat these patients know each other. For this, it was kind of more easy possible, but it's really a bit more complicated to outreach. And it also has to do something with the incentive for the individuals or for the doctors, basically, that put their data into the database, as they don't have a direct benefit, but it takes a lot of time to do it carefully. So it's for us, it's still not solved. And as you mentioned, or as it was called in my title, how we could connect and join forces. So I will watch if you have some great ideas, and we can maybe replicate or vice versa.
I think that probably one idea is that it would be good to have pilots by areas like yours that are very advanced and try to see if that works for you. Probably it may work for other conditions. Well, I remind everybody that they are allowed to put questions. So if you want, just unmute yourself or raise your hand and say something. Please, Giselle, I'm sorry, I stopped.
No, that's fine. I was just going to say that I think we still need some brainstorming and exchange, and as you said, some pilot study on very reduced data set, and to see how it works. Because as Carl said, the validation step is essential for me, because we are dealing with treatment, and you need to have already, when we make the systematic literature review, you need to use standard of validation of treatment and grade about the efficacy, etc., etc. So we need to envision all the different steps and difficulties there to be. There is two steps for me. There is being able to have people feeding some data, and then to be able to validate and be sure that it's correct without much added work burden on a lot of people. So IT tool can help to speed things, but at the end of the day, you need people behind to validate for disease expert area. So far, I don't see how to avoid this step. We need to have
a few more years, and artificial intelligence will solve the problem. Probably.
Yeah, maybe I'm too old to have a very prospective view of the future with IT.
Well,
Leslie,
we are not. Yeah.
Leslie, raise her hand.
Oh. Yes, if I can ask a quick question for, I think it's for Giselle and Katja. For now, you have envisioned to collect information from publications or clinical trials. But have you thought about also adding entries from clinicians that might have tested a treatment in a patient and it worked, but have never published that information?
As I said, for me, why not? If it goes through the process detailed by Carlos, what is needed at the end, it's how do you validate this? So far, and it's my thought, but I'm happy to hear something else. There is some peer review of the effect of any treatment or that are published, and that doesn't mean that it does not exist, as you say, Leslie. That maybe someone test a treatment in a patient, it was efficient in one patient, but what can be efficient in one patient, does it be okay to translate to every patient? There is some rules, some controls to get there, and this all about what I put on the bracket validation step. Yeah. Either by peer review or by expert or discussion, but at this stage, again, but I'm perhaps not good enough in artificial intelligence. I don't see how we can avoid this validation step.
Of course not. That was a provocation.
And I know.
I suppose that the regulatory agencies will want also a word about that. I think
Katja raised.
I just wanted to comment because the validation actually is even a bit problematic with the published literature, because if a doctor says my patient responded well, what should the reviewer say about this? And so you cannot really control for the correctness of the published data, even of the published data. But I see more the problem of really having the incentive or the initiative from a clinician to say, oh, I treated 10 patients and I put my data in a systematic database. I think not so many clinicians are willing to do so. But if there are some, then we should encourage them to try it out, to contact us or you or whoever is responsible for this disease, and to see what to do and to start the process. But I think there are not so many that are willing to contribute. And there should be even maybe more initiative to encourage clinicians to share their data.
Yes, we could go on. We could discuss text mining and other things, but I think we can organize perhaps another webinar for that. And today I'm going to finish by thank you everybody for attending, and thank you in special to Giselle, Katja, and Carves for their wonderful participations. And I'm glad that we started some dialogue, and we'll be probably back sometime in the future to expose or to promote the evolution of this platform that is in its early days. So thank you very, very much, everybody, and see you very soon, I hope.